Hey everyone, welcome to this video. In this video, we'll be looking at how to create an EKS cluster. So the link to this repository will be given in the description. And as you can see here, there is a cluster creation.md file. And this contains the steps that you need to create an EKS cluster. The prerequisites is AWS CLI. You should have that installed. You can check it out either on AWS documentation or follow these commands. And after AWS CLI is installed, you'll have to run commands like AWS configure, or if you have SSO access, AWS configure SSO and configure your AWS CLI. This helps you operate AWS operations on the command line interface. After AWS CLI is installed and configured, you will have to install eksctl. Eksctl is a command line tool that is used to create and manage resources on EKS, that is Elastic Kubernetes Service. This makes things much easier instead of manually creating resources on EKS, which might be very long. This will automatically create the whole architecture that we need. We will be looking at what and all this will create. Firstly, it will create a VPC with managed rules, and inside the VPC it will create a cluster of our requirement and set up networking and everything automatically. So this will reduce a lot of manual effort. So installing eksctl is very important. You can also look at AWS documentation for this. Then after these two are the prerequisites. After these are installed, then we can move on to the cluster creation part. So in EKS, you can create two types of nodes, that is either a Fargate type of instances which are self-managed, or we can have EC2 as the node groups. In this project, we'll be following EC2 as the node groups, and for cost saving purposes, I am using Spot Instances now. And if we look at the command here, this is the command to create, that is eksctl create cluster, and you can specify the name of your cluster and the region where you want it to be created, and how many nodes you want the cluster to have, and what are the minimum number of nodes and maximum nodes, and the node type of the underlying EC2 instance will be T3 medium. You can change it as per your requirements. And as you can see, it is EC2 Spot instance that is being created. This will take some time to execute for the whole thing to set up, because as I said, it will be creating a VPC and a lot more things which we will be looking at practically. So this will take some time. After this is done, then we'll have to update the kubeconfig file. You can see to enable kubectl to authenticate with the EKS cluster with the name of the cluster that you have created, you have to run this command. Then afterwards, you'll have to associate IAM OIDC provider. I'll be showing this practically as well, then it will be easy to understand. So now let's move on to the demo. As you can see, now in my terminal, I have AWS configured. And I also have AWS CLI. At AWS, you can see it's not red anymore, it's blue, which means it's installed. Just hit AWS. AWS is installed, and then eksctl is also installed. So make sure you have these both installed. So now the prerequisites are met. Let's get started with the cluster creation part. I'll just be copying this command and pasting it. Let the name be demo cluster itself, but I'll reduce the number of nodes. I think 2 nodes will be sufficient, and minimum nodes can be 1 and maximum nodes can be 3. And hit enter. This will begin the cluster creation process. As you can see, it started in the region that we preferred, AP South 1. You can change it to US East 1 or whatever you want. Then as you can see, the subnets are created automatically, and CloudFormation stacks are also used. These CloudFormation stacks will be used to deploy the cluster. and this process of building and deploying the cluster will take some time. This whole thing will happen using CloudFormation stacks only, so we'll have to wait for some time for this to be done. Now as you can see, the cluster is created. It is ready in the AP South1 region as specified. And one thing I forgot to mention was one of the prerequisites is having kubectl as well. I have anyways added that to the readme file. And this kubectl command is very important for interacting and managing Kubernetes resources on the cluster. And I have that installed as well. You can follow these steps and install kubectl as well. And now that we have this cluster ready, let's look at our AWS console and see if it's created. Let's head to Elastic Kubernetes Service. And as you can see, there is a demo cluster that's created 14 minutes ago. It took around 15 minutes for the cluster to be created. And let's look at the resources section. These are by default the pods that we need for networking within the cluster that are being created. And then compute type, as we've specified, there are 2 nodes that are created of the instance type T3 medium, and these 2 nodes are part of this node group. And in the networking tab, we can see it is launched inside a VPC. Let's take a look at the VPC. This is not a default VPC, as you can see. So this was created using the eksctl command and the networking for this. As you can see here, creation of 3 subnets, and this whole networking was taken care by that single command. This way it reduces a lot of work. And yes, so this is our cluster, and we will be deploying resources in this cluster. But before that, there are a few steps that we'll have to do. First one is update the kubeconfig file. So this will help us use kubectl commands on our EKS cluster, to put it in simple terms. So let's run this command. So now the file is updated. And this is an important thing to associate IAM OIDC provider. So if we take a look at the cluster, there is something called OpenID Connect provider. So this is the IAM OIDC provider that we will have to associate. And this is for basically, this provides the cluster with IAM roles that it needs to use other AWS services. So let's associate this as well. Yes, so the cluster is created and it is ready for deployment. And in the next videos, what we will do is we will create a .github/actions file in the root of this repository, which will help us run CI/CD operations for continuous integration and continuous deployment. And then we will do that using the Helm charts. As you can see, there is already Helm charts present for the deployment of API gateway. I will walk you through how this is created and what it does, and then we'll see how CI/CD is done. So that's it for this video. Thank you everyone.